My name is Johnson Elrod. This is a concept video that's going to cover some of the ideas from the projectile unit. I created a scenario here and parts that have questions within them that should address some of these ideas. So let's go through it. The scenario is Tom and Jerry stand on the edge of a 100-meter high cliff. Tom reaches his arm over the side of the cliff and throws a ball straight up in the air with an initial speed of 15 meters per second. Jerry throws an identical ball at the same release point with the same initial speed, but he throws the ball at a 45-degree angle above the horizontal. This diagram here illustrates this scenario. Tom's ball is in the dashed line, Jerry's ball is in the solid line. Tom's ball, while the diagram shows a very slight arc here, is thrown straight up. Because this is two-dimensional, I had to show this. But ideally, just know that this ball is straight up and down. There is no horizontal component. Jerry's ball, on the other hand, is released at an angle. And so it takes the same path as the parabolic path that most projectiles take, because it was released at an angle. It has a horizontal component. The first part of this scenario that we're going to be going over is we're going to assume that the ball is at the highest point or the peak. Now, the first question that I have with that is which ball had the greatest horizontal velocity at its peak? As I just said a second ago, Tom's ball has no horizontal velocity. Jerry's ball does. And so that, obviously, the fact that Tom's has 0 and Jerry's has any, this would mean that, of course, Jerry's ball has the greater horizontal velocity at its peak. The second question is going to be which ball had the greater vertical velocity. This is something that almost like a trick question, but if you think about it, it's really pretty simple. When all projectiles reach its highest point, that is the transition from positive to negative direction. And for a split second there, when it switches, that vertical velocity becomes 0 because it is not going positive or negative. This is true in Tom's ball's arc as well as Jerry's. So in both situations, the vertical velocity is going to be 0. Now the third question that goes along with this is which ball's velocity vector has a greater magnitude? Both are released with this same initial magnitude. However, Tom's ball has no horizontal direction. You use a Pythagorean sum to figure out the magnitude, and because Tom's lacks any sort of horizontal direction, and Jerry's has a non-zero horizontal component, that can only mean that Jerry's ball must have a greater magnitude. Now the second part, or part B of my scenario, is going to come on this page. Which ball reaches its peak the quickest? Now, both were given the same initial speed or initial magnitude. However, Tom's ball does not have to split up any of that energy or speed into vertical or horizontal components like Jerry's ball, or rather only the vertical component. And because none of that has to be shared, that means that all of it goes into the vertical, which means that it's going to take it more time if it has to go higher than Jerry's ball. Jerry's ball has it's split up into vertical and horizontal components. And with the same force acting against them, that means that Jerry's ball is going to reach its peak quicker than Tom's ball is. And so that's the answer to that one. Now we move on to C, the third part of this scenario. And we're going to assume that the ball is at the moment immediately before impact. And the first question to go along with that is going to be which ball has the greater vertical velocity. So we're only talking about greater vertical velocity here, not horizontal. And if we think about that, then when we look at the diagram here, forget the paths that they take. Only look at the height, because that's the only thing that matters here, of both balls here, okay? Now, clearly Tom's is higher than Jerry's ball. And if we just think about dropping two balls from different heights, it's easy to realize that the ball that is dropped from the greater height is going to reach the ground at a greater vertical velocity, at least a greater velocity than the ball that is dropped from a lower height. It has more height, it has more room to go, and so it's going to build up more vertical velocity than Jerry's ball will, which is just not as high as Tom's. So there's that one. And the second question to part C is, which ball's velocity vector has a greater magnitude? Now, if we think about this, both balls started off at the same initial speed. We said this, and regardless of whether or not either ball was whatever angle they were released at, or one of them wasn't released with an angle whatsoever, when you think about energy and speed can be directly connected, it is kinetic energy. If both are given the same kinetic energy at the beginning, it doesn't matter what, and they were both released from the same height, it does not matter whatsoever what path they took. Along their paths, the same amount of kinetic energy was absorbed or created, or not created, but the same amount of potential energy was lost, and the same amount of kinetic energy was increased in both balls. And so the answer to that one is that the magnitude would actually be the same in the final magnitude would be the same in both situations. And so I think I hit some pretty core concepts of projectile motion, and hopefully this helps somebody. Thank you.